On a crisp July night in 2025, a faint speck of light flickered across the star-strewn sky above Chile's Rio Hurtado Valley. The Atlas telescope, ever vigilant in its planetary defense mission, caught it. A ghostly point, barely magnitude 18, gliding just above the galactic plane in Serpens Cauda. At first, astronomers thought it was just another minor planet drifting through the cosmic void, but something about its motion didn't add up. Larry Deno, a sharp-eyed researcher sifting through the data, noticed the object's path sliced across the starfield at an angle that defied expectation. Within hours, the global astronomical community was buzzing. The Minor Planet Center slapped a temporary code on it, 11PL3Z. By morning, it had a name, 3I/Atlas, the third interstellar object ever confirmed to visit our solar system. What followed was a cascade of discoveries that would challenge everything we thought we knew about the universe, leaving scientists and soon the world grappling with questions too big to ignore. Was this a random cosmic traveler, or something far stranger? And why did its every move feel like a deliberate step in a dance we couldn't yet comprehend? The discovery of 3I/Atlas on July 1st, 2025 wasn't just another notch in the astronomical record. It was a seismic event, a rare glimpse of something born beyond our solar system, racing through at 58 kilometers per second, fast enough to cross the distance from Earth to the moon in under 2 hours. For context, that's more than twice the speed of most asteroids. Unlike comets from our own Oort cloud, which loop lazily around the sun, 3I/Atlas followed a hyperbolic trajectory, unbound by our star's gravity. Its path was a near straight shot, barely bending as it tore through the solar system. Early estimates pegged its size between 10 and 30 kilometers, making it the largest interstellar visitor ever recorded, even at 4.5 astronomical units from the sun, roughly the distance to Jupiter. It shone brighter than expected, its coma already forming a glowing halo that hinted at something extraordinary. Astronomers worldwide turned their telescopes toward this cosmic interloper. The Zwicky Transient Facility and Pan-STARRS dug through archived images, confirming 3I/Atlas had been lurking in our skies since at least June 14th, 2025. Each new data point sharpened the picture. This was no ordinary comet. Its eccentricity, a measure of how stretched its orbit was, clocked in at over 6.2, shattering the record set by 2I/Borisov in 2019. For comparison, even the famously odd 1I/Oumuamua, the first interstellar object spotted in 2017, had an eccentricity just above 1. The path of 3I/Atlas traced back to the thick disk of the Milky Way, a region teeming with ancient stars, suggesting an origin older than our own 4.6 billion year old solar system. 3 interstellar visitors in less than a decade after billions of years of silence felt like a cosmic coincidence too stark to ignore. The odds were vanishingly small, and the questions were only beginning. As observatories across 3 continents tracked 3I/Atlas, the data painted a picture that defied every textbook. Most comets, even those from the distant Oort cloud, follow predictable arcs. Their paths curved sharply by the sun's pull, but 3I/Atlas moved with a precision that seemed almost unnatural. Its orbit was so straight, with an inclination just a few degrees off the ecliptic, the plane where all major planets orbit, that the odds of such an alignment were less than 1 in 500. Then came the planetary flybys. On October 3rd, 2025, it would pass just 28.96 million kilometers from Mars, about 75 times the planet's radius. 4 weeks later, it would skim 97.15 million kilometers from Venus. By March 16th, 2026, it would swing within 53.7 million kilometers of Jupiter. These weren't close shaves by asteroid standards, but for an object from another star system, the geometry was uncanny. Monte Carlo simulations, run on NASA's JPL Horizon system, pegged the odds of this precise sequence at less than 1 in 20,000. It was as if 3I/Atlas was threading a cosmic needle, surveying our solar system planet by planet. The brightness was another anomaly. At 4.5 astronomical units, 3I/Atlas was already outshining comets at similar distances, its coma glowing with a vigor that didn't match its distance from the sun. The tail, too, was peculiar. Not a broad, diffuse fan like most comets, but a a tight, focused column that pulsed in sync with the object's 16.8-hour rotation. Each flare coincided with a specific point on its surface, as if vents were opening only when facing the sun. Spectroscopy revealed a chemical makeup that raised eyebrows. Carbon dioxide dominated, outpacing water vapor by a factor of 8 to 1, 129 kilograms per second of CO2 against just 16 kilograms of water. For a comet, this was unheard of. Solar system comets typically vent water as their primary gas, but 3I/Atlas was playing by different rules. Trace gases like carbonyl sulfide and carbon monoxide appeared in ratios that didn't match any known comet family, and the dust grains were finer than a micron, too small for typical outgassing. One chemist likened the emission profile to a pressure valve, not a melting snowball. The data screamed for a new approach, one that could grapple with the sheer strangeness of it all. Classical computing, the backbone of astronomical analysis for decades, hit a wall with 3I/Atlas. Traditional algorithms which crunch orbits step by step couldn't handle the flood of variables. Speed, brightness, chemistry, and those eerily precise planetary flybys. The models kept diverging, producing a tangle of contradictory outcomes. NASA's Quantum Artificial Intelligence Laboratory stepped in, armed with a hybrid quantum workflow powered by a CUDA cluster of 124 H100 GPUs. This wasn't just a supercomputer, it was a beast designed to wrestle with the impossible, capable of modeling millions of scenarios in parallel. Unlike classical systems, which slog through one possibility at a time, quantum AI could hold every potential trajectory, every chemical signature, every gravitational nudge in superposition, a state where all outcomes coexist until measured. The simulation ingested terabytes of data, velocity, inclination, emission pulses, and more. Each variable was encoded as a quantum state, allowing the system to explore every possible path 3I/Atlas could take. What once took weeks on traditional supercomputers now finished in minutes. The results were staggering. The quantum AI didn't produce a single answer, but a probability cloud, a map of every possible fate for 3I/Atlas. At its core was a number that chilled the room, less than a 5% chance that this object was a natural random visitor, a chunk of ice and rock tossed aimlessly from another star. The other 95% pointed to something else. Controlled emissions, deliberate course corrections, a trajectory that seemed engineered. The simulation flagged the planetary flybys, Mars, Venus, Jupiter, as statistically improbable, a sequence that appeared in only a handful of millions of simulated universes without some form of directed input. The word intent began to creep into hushed conversations, not as a conclusion, but as a question too big to dismiss. The tale of 3I/Atlas was no ordinary comet tale. High-resolution images revealed a structure that looked less like a natural outgassing and more like the exhaust plume of a thruster. The gas and dust formed a tight, focused jet, pulsing in time with the object's rotation. Each burst, timed to the second, coincided with a specific surface longitude facing the sun. Spectroscopy added another twist. The tail was rich in carbon dioxide, but it also carried a metallic signature, nickel, with almost no iron. In natural bodies, nickel and iron are inseparable, forged together in stellar furnaces. Finding one without the other was like discovering a recipe with sugar but no sweetness. Nickel, a key component in high-temperature alloys like those used in heat shields and turbine blades, hinted at something engineered. The quantum AI flagged these pulses as distinct from random sublimation, grouping them closer to controlled venting than any known comet. The idea was almost too wild to entertain, but the numbers didn't lie. If the pulses were timed just right, 3I/Atlas could be using its own mass loss to steer, nudging its trajectory with each burst. Theorists began to whisper about plasma exhaust, about the possibility that this wasn't a comet but a craft. The analogy wasn't perfect, but it fit better than chance. Each pulse was like a swimmer kicking off a wall, a gentle push to adjust its path. The simulation couldn't confirm intent, but it showed the pattern was more consistent with purpose than accident. If the tail was a tool, not a byproduct, then 3I/Atlas was moving with a mission. The implications were dizzying. A visitor from another star, not drifting aimlessly, but navigating with precision, threading through our solar system like a surveyor mapping a new frontier. The trajectory of 3I/Atlas read like a cosmic itinerary. Its close passes by Mars, Venus, and Jupiter weren't just lucky shots, they were choreographed. Mars, just past opposition, was on the same side of the sun as Earth when 3I/Atlas made its closest approach on October 3rd, 2025. Venus nearing inferior conjunction was next. Jupiter, emerging from solar conjunction, completed the sequence in March 2026. The alignments were too perfect, the distances too tight. JPL analysts ran the numbers backward, searching for gravitational assists or prior encounters that could explain the path. Nothing fit. The trajectory was clean, hyperbolic, and untouched by recent planetary influences. It arrived from Sagittarius just above the galactic plane, moving too fast to be captured, too straight to be local debris. The quantum AI's Monte Carlo runs hammered the point home. The odds of hitting all three planets in sequence at these distances with this timing were less than 1 in a million. For comparison, Oumuamua and Borisov, the only other interstellar objects on record, cut through the solar system on paths that missed planets by hundreds of millions of kilometers. 3I/Atlas, by contrast, seemed to be conducting a survey, each planet a waypoint on a deliberate route. The simulation didn't just highlight the improbability, it suggested a pattern that natural processes rarely produce. If this was a fluke, it was a 1 in a million fluke. If it wasn't, the solar system had just hosted a flyby that defied every expectation. The question wasn't just what 3I/Atlas was, but what it was doing, and whether it was doing it on purpose.
The discovery of 3I/Atlas exposed a sobering truth. Our planetary defenses are not ready for something like this. In 2013, a 20-meter rock exploded above Chelyabinsk, Russia, with the force of 440,000 tons of TNT. It shattered windows, injured over 1,600 people, and slipped through every detection net, too small, too fast, and coming from a blind spot in the sun's glare. Now consider 3I/Atlas, at least 10 kilometers wide, hundreds of times the mass of Chelyabinsk. It was only spotted because ATLAS caught a faint flicker against a crowded star field. Designed for near-Earth objects, the system struggles with interstellar visitors, especially those moving at 58 kilometers per second. If 3I/Atlas had been on a collision course, we might not have seen it until it was too late. The quantum simulation underscored the vulnerability. If an object this size, or one capable of adjusting its course, were aimed at Earth, our defenses would be little more than hope and hurried calculations. Atlas scans the sky 4 times a night, but it can't peer through the galactic center's glare or spot dark objects coming straight from the sun. The gaps in our surveillance are real, and the difference between a close pass and a catastrophic impact could be measured in hours. The Chelyabinsk event was a wake-up call. 3I/Atlas is a louder one. If the simulation's hint of controlled movement is right, the next visitor could be even harder to predict, and far more dangerous.
Every so often, the universe delivers a discovery that forces us to rethink our place in it. In the 16th century, Copernicus displaced Earth from the center of the cosmos. Galileo's telescope revealed moons orbiting Jupiter, shattering the illusion of a perfect Earth-centric order. In 1969, Apollo astronauts gazed back at a fragile blue marble suspended in the void. Each moment stretched our understanding, revealing a universe vaster and stranger than we'd imagined. Now, 3I/Atlas has handed us another such moment. Its improbable path, its engineered-like emissions, its eerie precision. These aren't just data points, they're a challenge to our assumptions. The quantum AI's output, with its less than 5% chance of a natural origin, doesn't offer answers, only questions. Is this a derelict relic coasting on a path set eons ago? An active probe steering itself through our solar system? Or something else entirely, a message written in orbits and odds? The simulation's probability cloud is a mirror, reflecting our uncertainty back at us. Less than 5% natural, it says, leaving the rest, 95%, to possibilities that range from the unsettling to the unthinkable. The controlled venting, the nickel-heavy tail, the planetary flybys, they all point to a pattern that feels deliberate, a cosmic choreography that defies randomness. If 3I/Atlas is a visitor with intent, it's a reminder that the sky is not a sealed vault. For centuries, the stars offered comfort, a sense of order, but each new window we we open. Copernicus's heliocentrism, Galileo's telescope, Apollo's view has shown us a universe that's indifferent, vast, and sometimes unnerving. 3i/Atlas is no different. It's a glimpse of something bigger, a hint that we may not be alone in the dark, and that we're not as ready as we thought. The deeper scientists dug into 3i/Atlas, the more its story felt like a whisper from the cosmos, a tale written not just in light and motion, but in the very fabric of time itself. The object's origin in the thick disk of the Milky Way, a region dense with stars that predate our own sun, suggested an age that could stretch back billions of years, perhaps to the galaxy's earliest epochs. This wasn't just a rock or a comet, it was a relic of a universe that existed long before Earth's oceans formed, or its first microbes stirred. The quantum AI's simulations traced its path backward, revealing a trajectory that emerged from a stellar nursery in Sagittarius, a region where ancient stars still burn, their light dimmed by eons of cosmic wear. The idea that 3i/Atlas could have been wandering interstellar space for billions of years, only to arrive now, in our fleeting moment of technological awakening, felt like a cosmic coincidence too profound to dismiss. Its chemistry, carbon dioxide venting in precise bursts, nickel without iron, hinted at processes forged in environments alien to our solar system, perhaps in the crucibles of stars long dead, or systems we can't yet imagine. The pulsed emissions, synchronized with its 16.8-hour spin, suggested a mechanism that could have been active for millennia, preserved in the cold vacuum of space. Was it a dormant machine activated by the sun's warmth, or a natural object sculpted by forces we don't yet understand? The simulation offered no certainties, only a haunting possibility. 3i/Atlas might be a messenger, carrying secrets from a time when our galaxy was young. Its purpose, if it had one, lost to the ages yet still operational, ticking like a clock that never stopped. As news of 3i/Atlas spread beyond the scientific community, it ignited a firestorm of curiosity, fear, and wonder across the globe. By September 2025, social media platforms were alight with speculation, from amateur astronomers sharing grainy telescope images to conspiracy theorists weaving tales of alien fleets. The mainstream media, too, couldn't resist the story's pull, with headlines screaming about cosmic visitors and interstellar mysteries. Scientists, cautious by nature, urged restraint, emphasizing that the data was still under review, but the public's imagination was already running wild. The quantum AI's findings, leaked in fragments to the press, fueled debates in homes, classrooms, and parliaments. Religious leaders pondered whether 3i/Atlas was a divine sign, while philosophers questioned what it meant for humanity to encounter something that might not be a mere rock. Governments, quietly concerned, convened closed-door meetings to assess the object's implications for national security, especially given its close planetary flybys and our limited ability to respond to a potential threat. The simulation's 5% natural probability became a lightning rod, with some dismissing it as statistical noise and others seeing it as evidence of something profound. Public forums buzzed with questions. If 3i/Atlas was artificial, who sent it? Why now? And what did it want? The global conversation mirrored humanity's oldest instinct, to look at the stars and wonder if something was looking back. For many, the object's eerie precision and strange chemistry stirred a primal unease, a reminder that we are small in a universe that might not be as empty as we'd assumed. Yet, amid the fear, there was hope, a shared sense that this discovery could unite us, pushing humanity to invest in better telescopes, stronger defenses, and a deeper understanding of our cosmic neighborhood. The departure of 3i/Atlas, as it races toward the outer reaches of the solar system, marks not an end but a beginning, a challenge to prepare for what comes next. Its visit has exposed the fragility of our planetary defenses, the limits of our understanding, and the tantalizing possibility that we are not alone. The quantum AI's probability cloud, with its unsettling 95% tilt toward non-natural origins, lingers like a shadow, urging us to rethink our assumptions about the cosmos. Scientists at NASA, MIT, and observatories worldwide are now racing to refine their models, poring over every spectrum, every light curve, every orbital tweak to extract more clues. New telescopes like the Vera C. Rubin Observatory, set to come online in late 2025, promise to scan the skies with unprecedented depth, potentially catching the next interstellar visitor before it slips through our blind spots. The global scientific community is calling for a unified effort, a network of observatories, quantum computers, and AI systems working in concert to track and analyze these rare travelers. But beyond the technology, 3i/Atlas has sparked a deeper shift, a collective awakening to the idea that our place in the universe is not guaranteed. The next object could be smaller, faster, or closer, and we may not have months to react. It's a call to action, not just for scientists, but for all of us. To look up, to question, to prepare. The stars have always held our dreams and fears, but now they hold something more. A mystery that demands we keep watching, keep learning, and keep asking what else is out there. The eerie precision of 3i/Atlas's journey through our solar system feels like a cosmic dance, choreographed with a grace that challenges our understanding of chance and chaos. Each step, its near-ecliptic trajectory, its pulsed emissions, its uncanny planetary flybys, seems to follow a rhythm that resonates with intent, as if the object is not merely passing through but performing a deliberate sequence. The quantum AI's simulations, crunching billions of possible outcomes, revealed a pattern too intricate to dismiss as random. The object's alignment with the ecliptic, a plane so thin in the vastness of space, defies the scattershot paths of most interstellar visitors. Its velocity, clocking in at 58 kilometers per second, carries it through the solar system with a purposefulness that feels almost alive, as if it were navigating rather than drifting. The chemical anomalies, carbon dioxide venting in controlled bursts, nickel without iron, suggest a composition that could belong to a machine, not a natural body. These bursts, timed to its 16.8-hour rotation, align with solar exposure in a way that mimics a thruster firing at precise intervals, nudging 3i/Atlas along a path that threads through Mars, Venus, and Jupiter with surgical accuracy. The simulation's probability cloud, with its stark less than 5% chance of a natural origin, paints a picture of an object that might be more than a relic. It could be an active participant in a cosmic narrative we're only beginning to read. Imagine for a moment a probe launched eons ago, its makers long gone, yet its system still humming, steering it through the galaxy to collect data or deliver a message. The idea stretches the imagination, but the data keeps pulling us back to it. The dance of 3i/Atlas, with its synchronized steps and improbable alignments, invites us to wonder, is this a performance meant for us, or are we merely spectators to a routine set in motion long before humanity existed? The answers remain elusive, but the questions it raises are a melody that lingers, urging us to keep watching the skies for the next verse. The arrival of 3i/Atlas has done more than spark scientific debate. It has held a mirror up to humanity, reflecting our hopes, fears, and vulnerabilities in the face of the unknown. As the object's strange behavior became public knowledge, it stirred a global conversation that transcended borders and cultures, uniting people in a shared sense of awe and unease. Scientists, philosophers, and everyday dreamers alike found themselves grappling with the same questions. What does it mean to encounter something that might not be a mere rock? Could 3i/Atlas be a sign that we're part of a larger cosmic community, or a warning that we're unprepared for what's out there? The quantum AI's unsettling probabilities, 95% leaning toward non-natural origins, forced us to confront our place in a universe that suddenly felt less predictable. For some, the object's precise flybys and engineered-like emissions sparked excitement, a chance to glimpse technology or intelligence beyond our own. For others, it was a chilling reminder of our fragility, a world still reeling from the Chelyabinsk impact of 2013, where a small rock caused chaos without warning. The global response was a tapestry of human emotion. Astronomers stayed up late, poring over data. Artists painted visions of alien crafts streaking across starry skies. Parents told their children bedtime stories about a wandering star that visited our home. Social media became a canvas for speculation, with hashtags like #AtlasMystery trending as people shared theories, from ancient alien probes to natural anomalies sculpted by unknown physics. Yet, beneath the excitement, there was a quiet dread, a recognition that our technology, for all its advances, might not be enough to protect us from the next visitor. 3i/Atlas became a catalyst, pushing governments to fund new space initiatives, inspiring students to pursue careers in astronomy, and reminding us all that the universe is not a backdrop but an active stage. This mirror in the stars reflects not just what we know, but what we must learn, urging us to build better tools, ask bolder questions, and prepare for a future where the line between natural and artificial blurs. As 3I/ Atlas slips beyond Jupiter's orbit, fading into the cosmic dark, it leaves behind a legacy that will shape humanity's relationship with the universe for generations. Its visit was brief, just months in our solar system, but its impact is enduring, a question mark etched in the heavens that demands we keep searching for answers. The quantum AI simulations, with their stark warning of a less than 5% chance of a natural origin, have rewritten the rules of what we believe is possible. The object's pulsed emissions, its nickel-heavy tail, its improbably precise flybys. These are not just data points, but clues to a puzzle that could redefine our understanding of the cosmos. Scientists are now racing to upgrade our planetary defense systems, with projects like the Vera C. Rubin Observatory and next-generation quantum computers poised to catch the next interstellar visitor before it surprises us. The global scientific community is rallying for a unified effort, proposing a network of telescopes and AI systems to monitor the sky with unprecedented vigilance. But the legacy of 3I/Atlas goes beyond technology. It's a wake-up call to our shared humanity. It has inspired a new generation of explorers, from students tinkering with backyard telescopes to engineers designing spacecraft to chase future visitors. It has sparked philosophical debates about our role in the universe, with thinkers asking whether we're ready to meet a civilization that might have sent something like 3I/Atlas. The object's departure doesn't close the story. It opens a new chapter, one where we must decide how to respond to the possibility of intent in the stars. Will we invest in the tools to protect our planet, or will we let this moment fade, only to be caught off guard by the next cosmic intruder? 3I/Atlas has left us with a choice: to remain passive spectators or to become active participants in a universe that's alive with mystery. So what's your take? Is 3I/Atlas a fleeting curiosity, a relic of a lost world, or a sign of something watching us? Share your thoughts below and let's keep this cosmic conversation alive. The stars are calling, and it's up to us to answer.